Welcome to another edition of the UW Reality Lab lecture series. We're joined by a very special guest today, Dr. Bob Crockett. He has been working over the past 3 decades in aerospace, biotechnology, medical devices, and consumer products, leadership roles in strategic and tactical side of engineering and IP development. He is actually now the co-founder of Haptics back in 2012, working in that space as well as serving as a faculty and associate dean for innovation infrastructure in the College of Engineering and professor of biomedical engineering at Cal Poly. And so he's going to be giving us a talk today about the work that has been happening at Haptics for, I guess, almost the past decade now, and how their journey has gone in terms of developing haptic feedback devices for virtual reality technology. So Bob, I will hand it off to you.
All right. Thank you, John. And John, before you go too far away, I was going to ask you, in preparation for this lecture, I checked out the class. It looks like a really interesting class, and I couldn't help but notice the instructor photos. It looks like you're wearing one of our gloves. Is that true?
Yes. Yeah. That actually, I forgot about that. But yeah, my profile photo for the class is actually when we visited your office a couple of years ago and got to test out one of your prototypes.
That's wonderful. Yeah. Well, good for you. I didn't know if that was just to make me feel at home, but thank you. It's good to see.
No, I quite like that photo. I think it's really fitting.
So hello all. It's wonderful to be with you. You know, of course, I'd rather be with you in person in a classroom, but this is the modern world we live in. So I'm glad I at least have a little bit of time to spend with you this morning to talk to you about Haptics and talk to you about Haptics, which is where the name came from. And honestly, this is an origin story. I can't promise the Marvel Cinematic Universe origin type story, but it really is intended to be less about a deep dive in technology, and it's not a 1 hour long ad for Haptics. That's not what I want to spend our time talking about, although those are pieces of what this presentation is about. But I think it's important as innovators, as engineers, especially in a rapidly evolving field, to really understand what it takes to get a disruptive technology to market. And as John mentioned, we've been working on this for the last 10 years, over tens of millions of dollars, and lots of person hours getting to the point we're at right now. And we're by no means across the finish line. So this is kind of a snapshot at a work in process that has the potential to be a real game changer in the world of VR, but it's a story that's still being made, and that's kind of the theme for today. And if this was in person, it would be quite informal. In lieu of that, I would highly encourage you all to ask me questions throughout the presentation. I'm by no means looking for just a monologue to go on for the full amount of time, even though there is an opportunity at the end for questions and answers. If there's something that's interesting, or you'd like to take a side tour about anything I say at any time, then just please stop me and speak up. And I actually am energized by that. So that's not a divergence at all. So let me get started with my slide presentation. So as I mentioned, what I'd like to talk about, since I saw, again, when I looked at your class, and it's a capstone class, and you all are working towards being able to build cool stuff, and this story, as we go through it, is about building cool stuff, but it's not just the stuff itself. It's the ecosystem in which the stuff lives, and in our world, that means the business side of it. So just having a good idea is necessary, but certainly not sufficient. It starts you out on the road, but you really do have to blaze a trail to get from a good idea to an actual durable company that can make people's lives better in whatever way it does. So this is the starting point of the story, and this is where I enter the picture. This is the vision that was presented to me back in 2012 by Jake Rubin, and Jake, at that time, was an all of 20-year-old college dropout from Seattle. He had spent a quarter in biomedical engineering at WashU, not UW, but WashU, and quit to start a internet-based company. I don't even remember what the company was that he did, but it lasted a couple of years. It made him a little bit of money, enough that he could really execute his dream vision. And his dream vision is what he came to me back in 2012 to lay out. And of course, it didn't look like this. This is a nice fancy graphic that came a couple of years later as we tell the story. So you can imagine a 21-year-old college dropout cold calling a college professor who does work with technology development and painting a picture by doing a lot of arm waving and trying to sketch things out about this machine. And this machine, you strap yourself into it and you put on a set of VR goggles. And remember, back in 2012, VR goggles, VR headsets, the Oculus was just getting started. It wasn't owned by Facebook. It was very early in this current incarnation of VR. And I had never tried one on myself. And he's telling me this vision of being able to strap yourself into a machine, put the headset on, and if you do it right, you will lose any distinction between the real world and the virtual world. Because this machine, at least in theory, if you pixelate your body into sufficient resolution and you have an apparatus that can apply pressure to your skin in the same way that a contact of something real in the world, and if you had a system that could supply thermal transfer, so either apply heat to your skin across the entire body, or take heat away, so heat transfer, to simulate what happens when you touch a steel table versus a piece of plastic or a ceramic mug. If you could do that for touch and for thermal and for force, where you have many joints in your body, many degrees of freedom where you can move around. And if this machine was able to accurately simulate the torques on every single degree of freedom that you have on your body, that a real object would be. So if you're lifting a heavy weight, it's pulling down on your arm, it's providing torque to your elbow, to your wrist, to the joints in your hand, to your shoulder. At least in theory, a machine could provide the exact same literal physical stimulus that you would feel if you were interacting with real objects. And if you did it well enough, then you would create what we used to call, for those of you who are over 50, the holodeck. That was a Star Trek reference to the original and still best Star Trek. But it's the idea of a room or a device or a machine where you flip a switch and you are in whatever environment you can dream. And you can walk, run, fly, swim on Mars, do whatever you want in the virtual world. And of course, this is a natural tie-in to the world of virtual reality. It's just extending it from the field of vision over to your whole body. So this was 2012. You can imagine, this is my subliminal advertising. If you can see my image on my screen, I have a Haptex mug I'm drinking from. I'll do that occasionally. So 20-year-old kid calls me up, says he has a vision for the holodeck, and he'd like me to help him build it. I didn't hang up on him. I sat down with him. I met him in person, and I realized a couple of things. First of all, this isn't your average 20-year-old kid. I mean, I'm a college professor. I've known many 20-year-old kids, and I'm sorry to keep using that term, 20-year-old individual. There's lots of smart people out there. I could tell that Jake was very smart, but he also had a couple of key ingredients that it takes to really get out of the world of dreaming and inventing and into the world of executing a potentially paradigm shifting disruptive technology. And that was, number one, he had really done his homework. He spent, and it was clear that he had spent an unhealthy amount of time thinking about this problem. He knew what came before him. He knew the academic literature. He knew what sort of work had been done in providing those sort of sensations to the body, thermal and touch and force feedback. So he knew what was out there. He knew what was patented. He knew what potential opportunities there were. He had some ideas about how this would be executed. So he'd really done his homework. The other thing about Jake, and we might come back to this later, and certainly it's great to ask me questions about the founder of the company, because that really sets the stage for the company's DNA, and it really all ties back to Jake. What Jake is very good at, which engineers in general have a hard time with, is not just gathering and synthesizing information. That's the easy part. Learning about what's come before you, being able to put two and two together, figure out the puzzle. That is important. What Jake is able to do to this day is very rare in inventors and engineers in a more broad sense. And that's that he's as quick to discard ideas if new information comes in that makes them less valuable or less interesting. He's just as equally willing to discard ideas as he is to come up with ideas. And that in my mind is the one distinguishing trait, because engineers and inventors tend to fall in love with their inventions. And it's very, very hard to not waste time backing out of an idea that is your baby if new information comes up that pragmatically something is a better solution. And Jake was able to do that. So I spent a little bit of time with him. I learned about who he was and what this vision was. And so, by gosh, we got to work. In the summer of 2012, leading into 2013, we spent a lot of time thinking about this as a system. So Haptex, you will know us if you've looked up the company name or seen anything about us. You'll know us as a company that produces a pair of haptic gloves for virtual reality. But we didn't start out as a glove company, and we don't think of ourselves as a glove company. We were treating this problem of full immersion, full body immersion, as a system problem, meaning that a solution wasn't of interest or value unless it really could be scaled up to the entire body. And that meant that some of the things that you could do that would be easier, like solid state actuators, such as piezoelectric devices, just wouldn't scale across the entire body in terms of performance or in terms of cost or in terms of practicality. And so that was one of the other things that was really kind of unique about our approach compared to other people who have done haptics. Haptics have been around for a long, long time. We were not the first company to come up with the idea of an apparatus that tricks your body into thinking it's working with something it's not. But we really had a very system level approach. And at first we were wondering whether this would be a 20-year project to lay out the pathway to getting this system developed. And what we found early on is that, no, this isn't a 20-year project. It's audacious, it's complex, but it doesn't involve any breakthroughs in technology. It's again, back to a systems level problem. If you have good engineers taking off the shelf components and combining them in the right way, in the right system, if you have enough money, you can build this system tomorrow. That's what we realized. Of course, that was 10 years ago. So now we're getting closer to our original 20-year time frame. That's not because of technology limitations. That's just because of the reality of we didn't find somebody to give us $100 million to execute this all at once. We had to grow our business step by step. And that was the challenge. Early on, without a lot of money and with this very broad idea, we got a good picture of it on paper. And we also did a lot of technology development work. So we had to build proof of concept prototypes, little individual system level devices and component level devices that proved out our theories, that proved that pneumatics could provide the sort of actuation you need to simulate an interaction with your skin. And those hardware development projects really weren't for the benefit of investors. They were in many ways to convince ourselves that this could be done. So that was an important early stage of the process. And the output of that in the first year led to this monster patent filing that really is our foundational patent for the company. It's about 140 pages, and we really sat down and thought about every single way you could build this sort of device, this sort of system, not only today, but projecting ahead where electroactive polymers will be in 10 years and where some of these more exotic technologies will be 10 years from now. And we tried to think through, that was a very, I recall that time period very fondly. It was Jake and I sitting with a couple of cups of coffee and sketchbook and bouncing ideas back and forth of what could possibly done. And then I'd shoot down his idea and he'd come up with another one, and I would come up with a modification and he'd shoot that down. And it was a lot of fun thinking about all the different ways to make this system. And in hindsight, that was the smartest thing that we could do, because it really gave us not only the intellectual property foundation, so the ability to have something of value early on, which was our patent portfolio, but also really, really helped us understand this problem, not as a pair of gloves, not as an academic exercise, but really looking at the end state. What does this holodeck require? And then working backwards into what are the pieces of this that we need to do in order to kind of bootstrap our way there. We're essentially looking for the minimal viable product. If any of you have taken entrepreneurship classes, that's what we were developing, was what of this entire big, monstrous, hairy system, what's the minimum viable product? And it's so easy to again look back and say, well, of course, it's a pair of gloves, because humans do things with their hands. That's the first thing that you're going to do if you have this vision for a system that includes the whole world. Well, start with a pair of hands. Honestly, it was not that clear early on. There are a number of ways that you can simplify the system or take pieces of this system that would potentially have a market application. We spent a lot of time working on a lower body exoskeleton, for example. We spent time working on patches of what we called e-skin that would provide the thermal transfer. We were playing, to put it bluntly, playing with the technology and trying to find the right match for technology and market need. And it wasn't super clear early on that it would be gloves that we ended up with as our minimum viable product. But that was a really important time frame. The other thing I want to mention about this time frame is how challenging it was. And I want you to picture this, if you will. A 21-year-old, again, 20 now 21-year-old college dropout, and a washed out professor from a school somewhere in the central coast of California walk into a venture capitalist office, sit down and paint a picture of this machine where once you strap into it, reality and virtual reality blend together. That's a hard ask. That's a really hard ask for people to believe that that this could be done. And so usually within a typical 50-minute or 1 hour time slot that we had with a early investor meeting, it would take 50 minutes of that 1 hour just to convince them that this could be done. Because you can imagine, as any sophisticated investor or person who's been around technology should do, they were very arm's length at first. I mean, this sounds like kind of a crazy idea when there's not anything demonstrable to point to. We didn't have prototypes that we could really show at that point. So it was all going on faith. And after about 50 minutes of describing what we had in mind and how we could achieve it, we really did get to the point, get them over that believability hurdle. And I saw this time and time again. You could set your watch by it. 50 minutes into a 1 hour presentation, we had them. We had them believing that this could be done. But that meant we only had 10 minutes to try to convince them that we were the ones that were going to do that it wasn't some other company or some other group that was the one to do that. Those were really, really challenging meetings early on. And honestly, I mean, again, back to entrepreneurial terminology, if any of you have ever heard about achieving early financing rounds from angel investors or even earlier, the earliest money you get is sometimes called the triple F round. And that triple F stands for friends, family, and fools, because only those group of people will invest in an idea that early when the risk is so high that it's unquantifiable. A professional investor should not invest that early in a company that presents this kind of wild vision. In our case, because it was so wild, it was triple F, but even fools were investing early on. It was triple F, meaning friends, family, and fans. That third group of people were the people who knew it was stupid to invest, because it really was, but they just believed in the compelling vision. You know, that picture that I showed of someday this system will be built. You will go into a location, or you might have it in your own home, and you will enter a machine, and it will transport you physically, virtually, into an environment that doesn't exist, that only exists in a computer. And we had our early success in fundraising were for people who really did believe that vision. And we're willing to part with small amounts, you know, for wealthy people, $50,000 at a pop, invest that hey, let's give it a shot. So that's kind of how we got started, working our way towards what the minimum viable product was. And at some point we looked around and this is what we ended up with. That was an early marketing video that we put together, and I still like that video more than some of our newer videos. That was with the one glove prototype, the one that John may have tried. It was an early version of our gloves. The reason I like that video is because it shows the human side of what we're doing. It's less about the business applications that came later, and more about the impact that this sort of technology has on people. I mean, we are tactile creatures. We use our hands. It doesn't matter how cool the scene is in virtual reality. If you're underwater, you want to reach out and interact with the fish. That's human nature. And so virtual reality has all of the truly impactful features that you all are studying and developing and know very well about. There's no denying that it's a wonderful technology, but it's missing a piece of the puzzle. And that's really what touch provides. And when you see in that video, that little fox that jumps on the person's hand at the end of that video, that was something that we kind of put in as an afterthought in one of our early demos. We downloaded it from some asset store, and I got to tell you, that had more of an impact than most any of the other technology discussions we could have. When people see that little fox, and we had a deer walk around in your hand and lie down, we've had people cry over that experience. It's amazing what a little tiny animal can do, because we're human. I mean, we're talking about a very sophisticated technology, but we're also talking about a sophisticated technology being used by a human. And so when we got our heads straight and really thought about the minimum viable product, yes, it was a pair of gloves, because humans interact with their hands, and companies are very used to VR at this point in time, but they are also very, very aware of the limitations of VR and training. And we'll get to that in a second, but that really brought us to a pair of gloves. And honestly, gloves are about the hardest thing you can do. You know, when you talk about developing technology, in some ways, it's much easier to develop an exoskeleton than it is to develop a pair of gloves, because there's so many degrees of freedom when you move your hands around. Hands are different sizes. It's squishy, but it's squishy in different zones in different areas. Your sensors in your fingertips that detect tactile information are very, very closely spaced. It's the worst possible geometry that you could engineer for, but it's the most important geometry from a business perspective that you could engineer for. So we dove in headfirst and developed a series of increasingly refined prototypes that led towards the gloves that we're selling today. And what we realized along that way was just how complex this system had to be, and it really helped us shape the direction we're heading. So let me talk about the complexity of this system first, because it's an engineer's dream system or nightmare system, depending on how you want to think about it. But if you really want to do natural haptics, it's very challenging. Haptics are all over the place. I mean, they're in your cell phone, for gosh sakes. Anything that buzzes or has an interaction But most of those are what we call symbolic haptics. They let you know something is going on. They give you a tactile cue, but it does not feel like a button when you're pressing something on your iPhone. You know something's there. It's a cue, but it's an implied cue. It's not a natural sensation. And if you really want to trick the human body into thinking that you're interacting with a computer-generated object, you got to do two primary things. One of them is tactile feedback. And, do this right now. Push into your skin. You'll realize that when you are touching something, your skin is moving in by quite a bit, a millimeter or so on the finger. It's actually much even further on the arm. And by the time you get to your back, it could be on the order of a centimeter. And if you don't press into the skin to that level of depth, your body will not interpret that as a natural touch. It'll realize something is going on, but it'll feel like a buzz, or it'll feel like an odd and uncanny sort of sensation. So you got to push into the skin. The other thing you really have to do is prevent your fingers from going through an object that isn't there. That force feedback is the idea of being able to physically prevent motion in your fingers and stop you from going through a virtual object. So when you put those together, you think of a virtual interaction of a hand and a coffee cup. And the problem we have today is that if you don't have any kind of haptics, you're going to be a ghost in a VR world. You can see really cool objects, but you can't interact with them. With the haptic system, when you're picking up that glove, the combination of your hand actually physically being stopped around the boundaries of that virtual object, and the sensation that's the accurate pattern, because it's based on the underlying physics of the contact, of tactile sensation, the pattern on the underside of your hand, that combination makes your mind really believe that you're interacting with a solid object. So that's the fundamental principle of how our gloves work. And again, when you put that all together, here's again a graphic and marketing type photo of our gloves. This is marketed in this particular slide towards design. We really realized early on that we were not building a product that had any chance of being a consumer product in the near future. We're just not interested in that. There are so many compromises that you have to make in order to get down to even a $2,000 price point, which is really, really high end for many VR accessories. The number of sacrifices that you have to make really reduce the quality of the experience to a point where we didn't want to bother. So that will come. As with any evolution of technology, the price comes down, the quality goes up, and companies that know how to mass produce things step in, and that will naturally evolve. But in the shorter term, we're not trying to make a low cost product. The pair of gloves that we sell are very, very expensive, and they are marketed towards enterprise use. So we consider these to be a business tool. I mentioned that haptics is kind of the missing piece of the puzzle for virtual reality simulation and training. And companies have been aware of this for a long time. Companies really have embraced virtual reality as a training tool for all the reasons that you already know about. I mean, in software, you can change the environment, you can change the scenario, you can go through trial after trial after trial of simulation for firefighters or fighter pilots or electrical high voltage workers or whatever the training scenario in virtual reality is. But if you then are limited to standard controllers, you break the immersion completely. And in fact, there's a lot of studies out there that demonstrate that it's actually worse to train in virtual reality in a way that isn't natural than to not train in virtual reality at all. You build muscle memory. When you're a pilot and you're reaching over your head to flip a series of switches, you're not looking at them, you're feeling them. You have that tactile sensation of a certain shape, toggle switch, and certain force that you have to pull back on it, and a certain satisfying click. There's actually a term for that. It's called buttonology, knowing that buttons that you interact with have a very specific tactile feel. And that's all part of the training experience. So if you are limited to just virtual reality and keyboard entry or hand controllers, it's it's appropriate for some simulation and training, but not the high-end stuff. And so it was interesting as we had early prototypes of our gloves to start showing around to prospective customers. It was pretty common pattern. We'd go into a laboratory of usually an R&D engineer at a big company who is in charge of simulation and training, developing those sort of technologies, and they would inevitably reach into a desk drawer, pull open a drawer that was filled with a bunch of what looked like junk. It was old gloves and controllers and weird looking devices. And they would turn to us and say, look, we've been looking for what you say you have for the past 10 years. All of these suck. They don't do what we need them to do. Let's take a look at yours. And it was not until we actually had a prototype of a glove that people could try on that we could, for the first time, have a genuine discussion about what this business tool could do to their business problem of high-end simulation and training. And that's where I would say, for the first time, this technology became real. It became not just an interesting technology, not just a vision. It became something that people were willing to pay for and actually pay a lot of money for. So I'm gonna pause there so I can have a sip of coffee, and I want to ask the entire group if anybody has any questions at this point that of anything I've talked about that sparked your interest or made you curious or you'd like a little bit of follow up on.
If no one else does, I have a question.
Yeah, John.
Just kind of the initial direction you had with this. So you mentioned early on your kind of initial advertising was a little bit geared towards consumers versus towards businesses, but then you kind of saw that. It sounds like you saw that initial real interest was from businesses in this kind of larger scale. So was that actually something you were aiming for initially, was to have this be a consumer product from the beginning?
Honestly, we didn't know what we had. I mean, I think, and that's a general. I'll give you a couple of tips for all the students out there that may want to bring disruptive technology to market. The tip number one is it's okay to not know what you have. What we had early on was a vision. What we had early on was it was very clear in our minds of what we could do, but we really didn't know how that would turn into a business. And there's a very, very large gap between a vision or a technology and an actual business. And so, John, it wasn't that we were aiming for the consumer market. It's that we could very clearly picture consumers being able to use this sort of system and benefit from it. We were able to visualize that early on. But it wasn't until we really got down into the weeds, and that happened pretty quick, that we realized that this is not a consumer product. So we actually kind of went from vision to the reality of the technology being very, very expensive, to putting our head back up and looking at who would be willing to pay that amount. And that led pretty quickly to the fact that there was a good match between company needs for a business tool and the price point and performance of our product. So we started thinking about this tool less about foxes jumping into your hand and more about companies investing in this business tool as they would invest in a CAD system for things like advanced simulation and training, but also design. You can imagine in the automotive industry, having the ability to not just do a solid model of a new car and look at it in virtual reality, but to actually interact with it. So much of what a car design, that's why we're showing this one image, so much of a car design has to do with the feel, the emotional impact of it. And so it could be something as simple as reaching over and closing the glove box. Designers such as Nissan want to know what that feels like, what that sounds like, what the materials are that they're going to use. And the way they do that now is by making mock-up after mock-up after mock-up of the inside of a new car. And that costs a lot of money and it takes a lot of time. So if you had a complement to a CAD system that actually lets you sit in a virtual car and turn the knobs and do the reaches that you need, and then be able to make changes and do iterations of that sort of user interaction and actually feel the user interaction, then that's a powerful competitive advantage for that automobile manufacturer. So that's really tip number 2 is that when you're bringing disruptive technology to market, it doesn't matter how cool it is. It really doesn't. We had a lot of people sit down with us early on as investors and nod their heads and agree, wow, that's a really cool technology. Best of luck to you. See you later. Because we didn't have the business model around it. And in this particular case, we did find the match between a pain that industry has and that they're willing to spend money to solve, and the capabilities of our minimum viable product, which is, a pair of gloves. Any other questions before we move on? Okay. So just a little bit more detail about what the technology is. I mean, I understand that many of you are computer scientists in this group. We have a combination of technology needs for our product that spans computer science and mechanical engineering and electrical engineering and biomedical engineering and materials engineering, definitely. And then there's some other things like aerospace that come into it, but it really is a multidisciplinary effort to build this sort of product. And some of the key technologies are illustrated on this slide. I mentioned touch, the tactile part of it, and how you really have to push pretty far into the skin to get a natural haptic sensation. We do that with pneumatics. So we have 133 individual pressure points on the underside of your hand. It's primarily on the palm and on the fingertips. And those think of them as little tiny balloons. Each one of those little tiny balloons has an individual channel that goes back to a valve and an air compressor. And we have the ability to inflate those little balloons at whatever pressure you need, at whatever rate you need, at whatever location you need. And that's what provides that natural feeling of running your hand against something solid. The force feedback part of it, which is down in the lower left of this image, is achieved by a series of tendons. So if you can imagine little strings on the back of your hand and a brake with each of those strings, you could pull those strings tight and prevent your hand from further motion. And so that's what we achieve as force feedback. That's really not that sophisticated if you think about it. Your hand can move in many more ways than those tendons would be able to control. But for most of the interactions that you do with your hand, it's a gripping motion. It's an inward close. And so we don't have to worry about pulling your fingers back. Just preventing your hands from closing is sufficient for most all grip interactions that you have. In the upper right of this image, one of the things, again, you don't know until you get in there. And what we did learn early on was that we had to develop our own motion tracking system. So motion tracking is very common in virtual reality, of course, and there's a number of different ways that you can track the motion, in this case, the motion of the individual fingers. There's optical means, there's strain gauge, there's other types of sensors, but the way our system works is that it is taking all of its interaction data from a game engine of a video game development system. So Unity or Unreal Engine has all this physics going on underneath it. And when we have our avatar hand contacting an avatar coffee mug, we're detecting collisions and getting force vectors and information about that contact directly from the physics that's running below these video game engines. And if you're wrong, I mean, think about this. If you're wrong about where your hand is in relation to the surface of a table, and you want to get force information, but you happen to be embedded in the table because your position information is wrong, the forces are going to go through the roof, or you're going to be slightly above the table, in which case you don't have any forces. So you have to know exactly down to sub-millimeter accuracy where your hand is physically in order to get an accurate contact information that will provide then the accurate tactile sensation. And when we looked around, our goal, as should be any good engineer's goal, is to not invent it yourself if somebody else has already done it. And we looked out there at all the different ways to achieve this and realized that there was one system. It was a magnetic tracking system that met our specifications, and it would have doubled the cost of our glove. So we built our own one, and that wasn't by choice. It wasn't because we just love to build things, although we do. but you only have a finite amount of money and time. We built it out of necessity. So we have a very accurate motion control system. And then the fourth piece of the puzzle is, as I was alluding to, the way that our system interacts with game engines. All of the information about a simple contact is derived from the physics underneath Unity or Unreal. We can use either. We have software development kits for either of those platforms. And what's really neat about this, and again, from a business perspective, we didn't develop our own. We developed the software that interacts with Unity and Unreal Engine, but we didn't develop our own physics engine. If we had to do that, it would cost us tens of millions of dollars more. We used what was out there. The side benefit of that is that many of our customers already are very familiar with Unity or Unreal Engine, and they've already built assets in Unity and Unreal Engine. And for simple interactions like touching something, you don't need to do anything to use our gloves. You put our gloves on, you load up the existing model, and it just works because it's based on the underlying physics. And that's a huge benefit to the companies that might be interested in our system, because it means they can reuse all of the assets, the virtual assets that they've built up over years and years, and they don't have to start from scratch again. So, so some of this is brilliance. And hey, I'll take all credit for brilliance, even though it wasn't me, it was the team of engineers in our company. But a big part of it was also being at the right place at the right time. You could not have built our company 5 years earlier. And if you started 5 years later, it would be too late to get the competitive advantage. So we were the right group at the right place at the right time to take advantage of this convergence of different technologies that comprise our system. And this is what it looked like from a hardware perspective. Starting in 2015 with the first kind of real, before 2015, a lot of it was those proof of concept technology demonstrations that I talked about. They were individual little pieces of hardware that we didn't really show to anybody. We were mostly convincing ourselves that it could be done. 2015, we had been working towards a lower body exoskeleton. So this would be something that would let you walk in a virtual environment. And it is an important part of the system. But interesting, isn't it, in hindsight, how this is where we focused our early time and effort, and that has nothing to do with the product we're selling today. But I'd like to just, keep reminding you all, and remind myself, that we're not a glove company. We're a company that is developing a whole body haptic system, and being able to move around in that virtual environment is very important. So we learned a lot from those prototypes, although that's something that's shelved for some other time. We then got to this monster box, and I think John, before we started this class, John was mentioning how he put his hand in this box at one point back in 2016 as a student. Is that correct?
Yeah, somehow one of those ended up on UW campus, and yeah, really, really early days.
Yeah. And so this was essentially what you do is you take your hand and you put it up against a flat plate with the VR headset on, and you see a cartoon version of the box and a cartoon version of your hand in space. And then using a controller, you pick up different animals or vegetables. We had fruit. We had a can of Red Bull. We had all sorts of different virtual objects that you could put into your hand. And this was a technology demonstration. It wasn't intended to be a product. It was intended to showcase what our technology could do. So this is pre-glove, but it showed not only the tactile part of it. So you'd actually, if you put a can of soda in your hand and rolled it around, you'd feel the pattern that you'd expect if you had an actual can. But it also had thermal. You were able to detect the thermal cues of a cold soda or an ice cube, or we had a dragon come in and breathe fire on your hand. And it was pretty cool. It's still pretty cool. But it was this monster box, about half the size of a refrigerator, that we were lugging around all over Silicon Valley. And those were interesting days. You always look back at those days as thinking, wow, did we really do that? Yeah, we really did. And the best and brightest minds of that day were not investing in us because they were convinced that we could take that technology and pretty easily package it into a glove form factor, but it would be really hard to shrink that box down. And of course, the reality is absolutely the opposite. It was really easy to shrink the box down. That's just standard miniaturization of everything, and really, really hard to take that flat plate and translate it into something that is as movable as your hand. But we did it. And by 2017, we had a 1-glove prototype. And about a year later, we had a 2-glove, what we call development unit. We only made a couple of those. And they were still prototypes, but they really let our early customers try things out. We would let them borrow one of these development units for a period of time to do some early evaluation and try to think about how they would use our system in their business operations. And that's when we were having real discussions with real investors and real customers, and piece by piece, brick by brick, you build a company. And I would say that the company by this point was a real company with full-time employees, with a very clear technology roadmap, with some more sophisticated processes in place, and with the funding that was never a sure thing. In fact, there were some times that were really challenging, but we had enough momentum to see it all the way through. And so where we are today in that last picture is what we're calling DK2. So that's our second development kit. It's not, it's somewhere between a prototype and a full product. We're not making a lot of these. We're making more than the first development kit, but we're making a limited number of them and selling them. And it's an expensive piece of equipment, but we're selling them to customers who really are looking at how to make our product work within their business practice, so they're ready to buy large quantities of our glove when we're ready to sell them. And that will be sometime in the not too distant future. The biggest distinguishing difference between the DK1 and what we're calling the DK2 that's out right now, you'll notice that it's in a backpack form. And so that lets the user walk around. Mobility, being able to walk around in a virtual environment, was one of the things that we suspected, but we really found out when we were having these conversations with customers, just how important room scale mobility is for virtual reality simulation and training. And if we were completely tethered to a desk, that would reduce the attractiveness of our product. So we spent a good amount of time making sure that we have a convertible product. It can sit on a desk or it can be strapped to your back. And where are we leading to? Well, of course, we're going to make the glove more svelte. We're going to make it look more like a commercial product. That's the natural evolution. So the glove gets thinner and lighter and higher performance and closer to your hand and better fitting and all the things and lower cost, everything that a product should do. But if you think about it, this is not a secret. It's physics. There are many things you can do with a pair of gloves alone. You can turn knobs, you can flip switches, you can rub your hand against the steering wheel. But when you start talking about heavier forces or heavier weights, a pair of gloves on their own cannot simulate a dumbbell, for example. There's nothing to actually pull your hand down in the way that an object that truly had mass would. You can't lean against the virtual doorway, you'd fall over because you have nothing to prevent you from falling. So again, this is not giving away our future products. This is just basic common sense physics. It probably makes sense to attach our gloves to some sort of grounded upper body exoskeleton that can provide the torques needed to not only be able to let you do things with your hand, but also feel the throttle and stick of an aircraft if you're flying a virtual aircraft, or lean up against a virtual desk, or lift an object that has actual mass. That's the sort of thing that you need more than just a pair of gloves to do. And then we have not forgotten our original vision that I presented you in the first slide of someday there will be a system. We hope to be the ones that brings it to market, where it's enough realism across the full body that it really does immerse you to a point where the virtual world and the real world are indistinguishable. One other thing I want to lob in there, I know we're getting near the end of the presentation time, but I put this towards the end because This is one of those interesting things that happens that are really hard to plan for when you're developing new technology. This is a lob in from left field that we did not expect. The idea of a haptic telerobot system started with almost like a hobby of ours. We had some partners that we were working with, some early customers, and we thought, wouldn't it be neat if you take our gloves and use them to control a pair of robotic arms that have anthropomorphic robotic hands on it. So very sophisticated hands that mimic all of the degrees of freedom of a human hand. And then combine that with very sophisticated sensors that accurately and very precisely mimic the way that humans perceive things. If you do that, then our hands with our motion tracking, as you move them around, could control the robot arms to move the robotic arms around, and control the robotic hands to interact with something that the robot is touching. And yet you as the user would feel everything that the robot feels. So essentially, you are embodying yourself in the robot. And in this image here, this was an early demonstration of this. You put the pieces together and you have an end-to-end system for telerobotic control. We're actually having the operator just look at the robot hands. And this is something you can do a Google search on. There's the one that we like to point to is Jeff Bezos in our robotic arms. It looks like any kind of, it looks like you would imagine a billionaire technologist to look like, with a big set of robotic arms and a kind of an evil laugh. But it's a compelling video that shows that you can put our gloves in and control a robot without any real training, because you are the robot. You feel what the robot feel. In this case, we're not in virtual reality, but if you can imagine a headset on there and a vision system that's at the right location for where your head would be if you were this robot, you are embodied. You are that robot. You see what the robot sees. You feel what the robot feels. You just do whatever natural motions you would do to pick up a coffee mug or take the cap off a radioactive waste container and do operations that you wouldn't want to have a human in there doing themselves. So this system was not something that we envisioned early on in the product development, early on in the company. But again, because it addresses a real pain. The real pain is that there is not a good telerobotic system out there today. You have limitations caused by the user interface. It's hard to control a very sophisticated robot with a joystick or with a controller. You want to be able to feel things. So this is actually turning into a product that we didn't expect. It's either, you could consider it a divergence from our plan, or you could consider it an opportunity that's actually very compatible and has the same foundation. If you embody a robot, it's the same sort of thing as embodying a virtual environment. You need to interact in a way that feels natural. I'm going to leave this slide here for Q&A, and this is the fun part. We don't know how this story ends. We're 10 years into this company. We've raised a lot of money. We have a lot more money to raise to get this out to market. We have a number of different markets that we could address. They're shown in the upper row there. The military market, certainly. B2B is business to business, so the enterprise market for simulation and training, or for design like the automobile that I showed, or LBE, that stands for location-based entertainment. Back to the first image of an amusement park type setup where you go somewhere and strap yourself in and pay for an experience. It could be consumer, although that's not part of our direct plan in the short term. You can imagine this being at a price point that everybody can afford it. It could be a continuation of the sort of work we're doing in research for NASA, for UW, for anybody that wants to study human interaction in virtual environments and being able to control that interaction. It's a really neat research tool. So yes, we'd love to do all those markets. You just don't have the time and energy to do all of those markets well. And then if you look down on the column to the left, there are a lot of different directions our DK2 system could go. We could focus all of our energy into developing that really svelte, cool looking next generation of gloves. We could just as equally take features out of our glove, reduce the number of pressure points, reduce the capabilities to get the price point down or to meet a very specific niche market. We could create that upper body workstation that I showed, kind of an upper body ability to simulate heavier loads. We could go all out for telerobotics. We could create more of the suit type of vision that we talked about in the earliest slide of being able to scale this across your entire body. Which one are we going to do? Well, again, we'd like to do them all. There's certainly the potential for any one of these. So you have this huge matrix of all the different possible things we could do and all the different possible markets we could enter. And this is the $1 million question. And I would very much encourage you all to think about this. What would you do? You can't do it all. There's not enough time and money to do these all well. Which one would you pick? So that's a rhetorical question. I don't expect anybody to have an answer for that right now. We struggle with this and think about this very deeply every day. But we'll see. Come back a couple of years from now and we'll see how well we did. All right, I'm out of lecture time, but I do believe we have class time. So I'll stop my sharing and open the floor up to any kind of questions.
Hi, so I have a question regarding the size of the gloves. I wonder, do you provide different size, like small or large size gloves, or do you allow users to actually customize their own gloves?
Yeah, that's a great question, and it's a challenge for us. For our development kits, we have what we call one size fits most, which means that our gloves have little adjustable straps. So there are little boas in there, kind of like the shoes that you lace up. In order to get a good tactile sensation, you really have to be able to have a good fit. You have to be able to have good contact between our actuators and the skin. If you have something that's oversized, you're not going to be able to get that correct filling. If you have something that's undersized, it's not going to be comfortable and you're not really going to know how far you're pushing in. So to your question, by the time that we have a commercial product that we're making in quantities, we have to have multiple sizes. One size fits all or fits most is not a good solution. It's kind of a compromise. So just like there are small, medium, large gloves that you can purchase, we will be making multiple sizes of gloves. At this point, I don't think we're going to have user customized gloves. That's certainly something that we could do. That's certainly something that the military or very advanced users might want. They might want a wider range of sizes or more customization as they do with gloves for pilots. But at a minimum, we have to create multiple sizes by the time we're selling a commercial product. Great question.
Yeah, thank you.
My question is whether Haptex or other folks in this sector have thought about how your gloves could be used by blind people to experience virtual reality in a richer way than they can now.
Yeah, again, that's a great question, and that's something that we are exploring with some researchers, some academic researchers at this point. And honestly, so I'm not involved in that project as much. I don't think the end goal of that particular line of research is experiencing VR as much as it's being able to have our gloves be a tactile input device, kind of like Braille, kind of like the ability to have infinite Braille reader system. So yes, that would be a very wonderful use of this. And yes, we are starting to explore that sort of work, but I don't think we've taken it into the world of having sight impaired people experience VR. I think that's a neat idea. I will mention as one coda to that is that up until now, we've really been limited in what we can do with our own device. So there are a number of things that would be really interesting to study. And we've had different researchers, academic researchers and government lab researchers reach out to us to try to explore some of these really neat ideas. And we just haven't had the hardware to be able to provide them. We can't do our own studies. We've been racing so fast and so hard just to get a couple of early products out the door, that it's really only now that we can, pause and take a deep breath and look at our own system in more of a broader research tool. So yeah, I'm encouraging outreach. I think we're setting up as a company, we're setting up it's a program to gain access to some of our development units for that sort of academic research, because that opens up all sorts of different potential markets for us, but potential uses for the technology. And if we can turn our system into something that really helps people, boy, that's a win.
Thanks.
Yeah.
So I think the Braille reader thing is super cool, and I wonder, have you ever run like any usability test stuff yet, or is it still in like a development?
For usability for what part of it?
For the Braille, like the Braille readers.
So we're just starting that work now. I mean, there are some things that you need to do to our gloves and to our software to make it compatible with a Braille type system. So we're just getting started on that.
Oh, yeah, that's super cool. And like, do you, I wonder, have you ever tried maybe adjusting like temperature at each pressure point, or like,
right?
Yeah, I'm not sure. Like, have you ever tried some like temperature things in your glove to just like give more enriched experience?
Yes. So temperature was originally part of that big box that I showed. That was part of our patent. It was part of our vision. It was part of our early prototypes. When we got to the glove, if you think back at what I was talking about with the minimum viable product, we had to figure out what is the configuration that we can build as early as possible before we run out of money that people need the most. And when you look at it through that lens, you realize that thermal absolutely is an enriching technology, being able to detect temperature and detect different types of materials. Yes, it's very immersive, but it's not a need to have for our early customers. It's a nice to have. And it's really, really hard to put thermal control into our gloves, into any sort of system. And that goes back to basic physics again. It's easy, relatively speaking, to move air around. You can move air from one place to another very, very quickly. It's really hard to move heat around. So transferring heat over a very short distance takes a pretty long time, no matter how you do it. And so it's possible, and we know how to do it, but it's complex, and it would make our system much more expensive. And that would take us longer to develop it, and it would mean a higher price to the people who want this technology early. So we made a business decision to just put that on the shelf, and it will come back at some time, but not for a little while.
Yeah, that makes lots of sense. Thank you.
I saw it on one of the slides that you can also feel different texture of objects.
Yep.
I wonder how well it is, how good it is right now, and how like it is like down.
Yeah, no, great question. So the difference between a contact, touching something, and a texture, feeling the roughness of a surface and being able to tell what material it is, the only fundamental difference is how far you're actuating it and how fast you're actuating it. So when I touch a coffee cup, any one of those bubbles in our gloves will expand to a certain height pretty slowly, on the order of 50 milliseconds or so. That's a natural touch. For a texture, it's lower displacement, but higher frequency. So when you're rubbing your finger against something and detecting a texture, that same exact hardware would be pushing in a little bit less far, and it would be vibrating or moving at a much higher rate. So, from our perspective, it doesn't change the hardware, it doesn't change the design. This is a good thing for computer scientists to hear. It's all about the algorithm. It's all about determining how to drive our hardware in a way that accommodates both large displacements at a low frequency and small displacements at a very high frequency.
I have a question more about the safety side of the technology. I think
Yeah.
a pitfall I've seen, at least with a lot of disruptive technology in the VR space specifically, is this concern, a reasonable concern for like privacy and security and safety of users, right? So I think most people have basically given up on the fact that like anything to do with audio visual, there's really not a lot of like safeties in place there. I guess the technology to the point where it's relatively secure, right? Like you're not going to blind somebody with a headset at this point normally. But getting into haptics where it's still in development, right? With your gloves, at least, I think I asked this question a couple of years ago when I was testing it out about how you use purely a braking system, right? So there's no possible scenario where like a malfunction happens and suddenly someone's finger gets broken because the system decides to like torque it in the wrong way.
Right.
But and I think it's a really honestly a genius philosophy to have, right? It's like it's not it's all reactive as opposed to being able to actively harm somebody. But as you're thinking about the future of this space, is that a philosophy you're going to try to keep going with, or you're going to have to start exploring more like really putting those checks in place on the software side of things in the future if you want to have more of those active systems?
Right. No, great question. Again, it's something we continually think about. Safety is going to be the number one criteria for anything we put out. And as you mentioned, for the glove, it's not that big a deal. By having a passive system like you described with the brakes, and by having physical limits on the pressure that we operate at, you're not going to be able to cause any kind of injury for somebody. But you can imagine by the time you get to that full scale version, if you do it wrong, those are if you're providing enough torque to a support structure that can accurately simulate stairs that you're walking up, well, by definition, you have enough torque to rip your arm off or rip your leg off. That's something that is real. You can apply the same design philosophy to a great extent. You can have systems that are passive in nature, where they don't put energy into your body. They prevent your body from exerting energy. So they're brakes instead of actuators. And that philosophy can be extended to a great deal. There are some cases and some designs where you would need to have a more active system. Fortunately, for us, we're not the only ones that care about this. There's a whole field of cobotics, of robotic systems that work in cooperation with humans, and all the safety that same sort of issues. These robotic systems could knock you out. They could rip your head off. But developing a combination of software safety, physical hardware safety, things like weak links or other types of hardware devices that won't allow a certain type of quick motion or stop, limit stops. So software, hardware, procedural safety issues, you need multiple layers to really ensure a safe experience. And that, again, kind of like the multiple glove sizes, that's not a nice to have. We will not release a product that has the ability to hurt you. That's kind of a ground rule.
It's awesome to hear. Thank you for bringing up that point about the fact that there's this whole domain already kind of researching this. I hadn't really thought about that.
Yep. Yeah, really, it really is amazing how cooperative technology is when you just happen to ride the right wave at the right time. All of these technologies of VR optics and robotics and pneumatics and all the components that go into our glove and the soft goods that make up the glove itself. All of these things, if we had to invent them all on our own, there's not a chance this system would ever come to life. It would take hundreds of millions of dollars. But by being aware of technology advances and picking the technologies that are at the right level of maturity, and then adding our own kind of uniqueness to it, we're able to put together a system with a much, at a much reduced cost. Although it's not an inexpensive system to develop. It's not at this point an inexpensive system to purchase. Any other questions from anybody? We have an office in Redmond. We're always looking for computer scientists. Go on our website. You'll see some job openings now, and it always changes. Our needs change as we evolve, but check us out.
Thank you so much, Bob, for being here today. This was a fantastic talk and a great conversation to have. I think this is a really good perspective that the students got, especially coming from more of this industry approach that you've had in developing this really innovative technology.
Thank you. It's been a pleasure, and I hope to see many of you in person at some point in time.